Hello everybody, welcome to the I Am IT Geek YouTube channel. My name is Shabazz Dar and as ever I am the IT Geek. Before we get started with this episode, we're starting a new module today on the AZ700 Designing and Implementing Microsoft Azure Network Solutions series. I want to say a massive thank you to everybody who subscribed. I finally hit my 1k subscriber limit, or not limit I suppose, milestone that I wanted to hit. I wanted to hit it really last year, but you know, can't always hit our targets, and I always set myself harder targets than normal, so I can, if I don't hit them, it's no big deal. But I finally hit it, so thank you everybody for that support, and I am going to be doing a 1k subscriber giveaway, so keep an eye out for that. But yeah, we're back with module 3, to start module 3 today of the AZ700 exam prep series, as I mentioned. So again, same format as all the last two modules. Will be me doing the theory, followed by Mohammed Sajid, a good friend of mine. You can see all the socials in the description, doing the sort of lab assignments. So let's get started. As I mentioned, we are starting module 3 today, so it's a big, very exciting. And module 3 is designing and implementing core application delivery services. And today we're going to start off by we're going to talk about designing and implementing Azure load balancer. So this is part 1. This is a two-part sort of topic. And the first thing we're going to talk about is mapping requirements to features and capabilities. Then we'll look at identifying appropriate use cases for Azure load balancers. And then we're going to look at choosing between public or internal load balancers. And then Sad is going to take us through a demo of choosing an Azure load balancer SKU and tier. Let's get started with that first topic, mapping requirements to features and capabilities. So I suppose, to actually map requirements for Azure load balancer, we first need to understand the features and capabilities. So the IP address of your Azure load balancer, it's the point of contact for your clients. These IP addresses can either be public IP addresses or private IP addresses. So the nature of the IP addresses determines the type of load balancer created. So private IP addresses, that sort of selection creates an internal load balancer, and a public IP address selection creates a public load balancer. So some of the differences there between the two types of load balancers. Another feature, capability, is a back-end pool. So load balancers instantly configure itself via automatic reconfiguration when you scale instances up or down. Adding or removing VMs from the backend pool reconfigures the load balancer without additional operations or steps. Scope of the backend pool is any virtual machine in a single virtual network. When considering how to design your backend pool, design the least number of individual backend pool resources, and that'll optimize the length of management operations. And there's no difference in the sort of data plane performance or scale. Another feature and capability is a health probe. So a health probe is used to determine the health status of an instance in the backend pool. So during the sort of creation of your load balancer, configure a health probe for the load balancer to use. And this health probe will then determine if any instance is unhealthy and if it can receive traffic or not. So another capability and requirement, or feature should I say, is load balancing rules. So a load balancing rule is used to define how incoming traffic is distributed to all the instances within that backend pool. So like a load balance essentially rule maps a given front-end IP configuration and port to multiple back-end IP addresses and ports. So load balancer rules are for inbound traffic only, so just key distinction there, make sure you remember that. Another one is high availability ports, another capability and feature. And so a load balancer rule configured with protocol all and port of 0 is known as a high availability port rule. This rule enables a single rule to load balance all TCP and UDP flows that arrive on all ports of that internal standard load balancer. Final sort of capability and feature that I want to talk about is inbound and outbound NAT rules. So an inbound NAT rule forwards incoming traffic sent to the front-end IP address and port combination. Traffic is then sent to a specific virtual machine or instance in that backend pool. Port forwarding is done by the same hash-based distribution as the load balancing. So let's move on now to identifying use cases for your Azure load balancer. So first of all, an Azure load balancer operates at layer 4 of that operating system sort of interconnection OSI model. Single point of contact for clients. Load balancer distributes inbound flows that arrive at the load balancer's front end to back-end pool instances. And these flows are according to configured load balancing rules and health pros that we discussed in the last slide. The back-end pooled instance can be Azure virtual machines or instances of virtual machines scale sets. So we talk about public load balance, as you can see on screen. This can provide outbound connections for virtual machines or VMs inside your virtual network. These connections are accomplished by translating their private IP address to public IP addresses. Public load balancers are used to load balance internal traffic to your VMs. Another type of load balancer is an internal private load balancer. So this internal or private load balancer is used when private IPs are needed at the front end only. Internal load balancers are used to load balance traffic inside a virtual machine. So this, load balance front end can be accessed from on-premises networks. It's ideal for hybrid solutions. So when we're talking about identifying use cases, public load balancer is probably better for public-facing, internet-facing services, whereas internal load balancer is probably better for hybrid sort of internal services. Let's talk about this sort of a global versus regional load balancer as well. So Azure load balancing services can be categorized along two dimensions: global versus regional, and HTTPS versus non-HTTPS. Global load balancing services distribute traffic across regional backends, clouds, or hybrid on-premises services. These services route end-user traffic to the closest available backend. They also react to changes in that service availability or reliability and performance. And this is in order to maximize availability and performance. You can think of them as like systems that load balance between application stamps, endpoints, or scale units, hosted across different regions or geographies. With the regional load balancer, these sort of services distribute traffic within virtual networks across virtual machines, or zonal and zone redundant service endpoints within a region. You can think of them as sort of systems that load balance between VMs, containers, or clusters within a region in a virtual network. So very much internal to Azure, whereas global is more kind of global across different regions. Just sticking with this topic at the moment for now. So why use an Azure load balancer? With Azure load balancer, you can scale your applications and create highly available services. Load balancer supports both inbound and outbound scenarios. Load balancer, it provides low latency and high throughput as well. It can scale up to sort of millions of flows for all TCP and UDP applications. So it's very reliable, very available, very scalable. Some key scenarios you can accomplish when using your Azure standard load balancer. They include, internal and external traffic. So load balancer internal and external traffic to Azure virtual machines. You can increase availability by distributing resources within and across zones. You can enable support for load balancing of IPv6. So if you have any applications that support it, you can load balance IPv6 traffic. It's secure by default as well. So the standard load balancing balancer is built on zero trust network security and very, very high security. Finally, it supports multi-region, so you can move internal and external load balancer resources across Azure regions. So let's talk about choosing between public and internal load balancers right now. As I've mentioned, with a public load balancer, you can provide outbound connections for virtual machines inside your virtual network. So this is done by translating that private IP address to a public IP address. So when we're talking, as I mentioned, anything web-facing, external-facing, not inside your network, your private network, that's probably where you want to use a public load balancer, like websites, for example, access to websites. And when you don't want to publicly expose those hosting services, put a public load balancer in front of them. And then internal load balancer. So again, this is private and it's used where private IP addresses are needed at the front end only. So this is you use it for internal or hybrid scenarios. essentially when you're not exposing anything to the internet and the outside world. That's where you use your internal load balancer. So again, depending on what your scenarios, you choose between the two. So it's now time to hand over to my good friend Mohammed Sajid. So thank you, and over to you, Saj.
Thank you, Shabazz. Hi, everyone. Welcome back. In this quick demo, we're going to take a look at looking at the SKU and tier for Azure load balancers. So for Azure load balancers, navigate to load balancers. And as you can see, you have 4 types: application gateway, front door CDN profiles, load balancers, and traffic manager. So for the standard load balancer, select load balancer and select create, which is the easiest way to look at the SKU. So if you're going to deploy this, you select your resource group, give it a name. Then you've got the option of SKU, type, and tier. So if you look at the information for the SKU, it says choose standard load balancer, network load balancing when extreme performance is required, coupled with low latency. Choose load balancer, choose gateway load balancers to deploy, scale, and run third-party applications in Azure. So if you look, you have the option of standard, gateway, and basic, and the type public or internal, and then tier regional or global. So standard with internal would only get you a regional load balancer. So if you wanted a global, you need to have it as a public. That goes for standard or for basic. As you can see, gateway is grayed out when you choose public. So with the gateway, if you were to choose internal, you can have gateway as internal, but you can't have it as global. It'll be gateway internal and regional only. So it's to one region, not global. So with the type, if you're looking at information that says you can use internal load balancers, load balance traffic from IP addresses. Public load balancers can balance traffic originating from public IP addresses. So your combinations are standard, public or internal. An internal will get you regional. If you want global, they need to be public, and that goes for basic as well. So public will give you both. So basic will give you public and internal, but only regional, not global. So the only way you can have a global load balancer is to have a standard SKU, public, and select global. Gateway will only give you an internal load balancer in regional, not global. Thank you for watching. Back to you, Shabazz.
Thank you, Saj. Again, another really informative lab there. Again, you can follow the labs yourselves. The URL to the GitHub where the labs are stored is in the description. So that lab was on choosing a load balancer, SKU, and tier. So a really good way to finish off this episode. So this is the start of module 3. So just touching the surface at the moment. Got a lot of really good, interesting topics. Again, thank you everybody for your support and subscribing and get me past that 1K. Keep on supporting me. If you're not a subscriber, why not? Get notifications when I do upload. I'm uploading a lot more recently. So thank you for watching, and until next time, goodbye.